Okay, some more of homework number 31, number 60. The integral from 0 to pi over 6 of the cosine of the negative third power 2 theta, sine 2 theta, d theta. And we'll write this a little bit more conventional exponential notation. So we see it looks like u to the n du, so I'll let my u be cosine of 2 theta, and I'll make my substitution. Now remember, when you make your substitution, you also have to change your limits. All right? So I've got to take the cosine of 2 times pi over 6. And if I take the cosine of 2 times pi over 6, I get pi over 3. The cosine of pi over 3 is 1/2. And then if I take, using this formula, cosine of 2 times 0, well, that's a cosine of 0, which is 1. So these are my new limits in terms of u. And there's my u substitution. And then I still got the sine 2 theta d theta. That's what I'm going to be looking for my match over here. So I can find out, first of all, what I'm going to do with the du over here. Let's move this over just a little bit. And on the right, we'll take the derivative of both sides implicitly. Du d theta equals negative 2 sine 2 theta times 2 d theta d theta. The d thetas become 1, but then I move this other d theta over. And I solve. And I have du over negative 2 equals sine 2 theta d theta, which is my match. I can also reverse these over here. And I'll have to change the sign from positive to negative to reverse those, so I can integrate from left to right. And I make this substitution. And then I'll move the negative 1 over 2 outside to be negative 1/2. And that times the negative is a positive 1/2. And I'm all set, ready to integrate. So I add 1 to 3, I get negative 2. So 1/2 e to the negative 2 over negative 2, evaluated from 1/2 to 1. And then that just becomes this. I can put the minus sign in front. 2 times 2 is 4. I can bring the u in the bottom. And this is what I want to go, so I got a nice easy fraction to evaluate. And over here I have this now. So when I put 1 in here, I get negative 1/4 and 1 over 4 times u squared, which is 1. That's no problem. And I got a negative, which is from the f of b minus f of a part, and this is the actual part that's in the antiderivative. And that's going to be 1 over 4 times, and then when u is 1/2, it's going to 1/2 squared, it's 1/4. So negative 1/4 plus, and that's 4 times 1/4 is 1, so we just have negative 1/4 plus 1. And that's just 3/4. So that's not too bad. Okay. All right, and the next one was number 62. If you have any problems with these, just email me and I can put a snapshot up. So you can, we didn't have enough time to see it all working with the camera here. Okay. So this isn't too bad. It looks like it's going to be 1 over u du. The derivative of this whole bottom thing will be just 2. So that'll be easy to fabricate. So I'll say 2 to 5 of 1 over 2x minus 3 dx. It looks like I'll let u equal 2x minus 3. Now again, I have to change my limits of integration. So I'm going to integrate here. And I'm going to have 1 over u dx. And then 2 times 5 minus 3 is 7. And then 2 times 2 minus 3 is 1. So those are my new limits. Now let's fix this dx. So it's a du. So du dx equals 2 dx. That's 1. Move the other one over. So we got du equals 2 dx. And bring that out in front. So I got du, or divided by 2 I should say, equals dx. And there's my match. So now I've got the integral from 1 to 7 of 1 over u times du over 2 and bring that out as 1/2. So I got 1/2 times the integral from 1 to 7 of 1 over u du. And that's just my nice natural log form. So that's going to end up being equal to 1/2 the natural log. And it should be the absolute value of u, but we don't have to worry about that. But we can write it down anyway, the absolute value of u from 1 to 7. That's going to equal 1/2 the natural log of 7. All right? Minus 1/2 the natural log of 1. But the natural log of 1 is just 0. So that's going to be, because either the 0 is 1. So it's just going to equal 1/2 the natural log of 7. So that wasn't too bad. Okay, we'll do some more in a moment.